we will create a PLC program for this simple car parking space, and then let us say we will just use these two servo motors for opening and closing the entrance and the exit gates. And then we have the sensor here for the entrance sensor. Whenever the car will go to the entrance, and then the sensor will be activated and the car will be counted as one. So the maximum value for this example only is 10 cars inside, and then when the car will exit, the counter also will decrement, and the gates also will be closed after the car will be exited. And then if the allowable number, so for example 10 is already reached, the entrance gate will be closed, okay, and no more cars can enter. And also for the exit, in this example only, if the car area is empty, the exit will not be open unless there is a car inside, and then the sensor will detect, and then the exit gate will be open. So we have two servo motors here as a prototype or just an example, and then we have two sensors in Arduino, and we have two 7-segment displays driven by BCD. Okay, so the program, if we will use a PLC Sim2, this one. Okay, so I will open the program that I have made. Okay, so we will load the program since it's already been created. Okay, so here I have used the equal operator. If the counter accumulator will reach 10, or it will trigger the B01. Okay, if the accumulator is 0, then it will trigger B00, so that we can control the counting up and counting down of the counter. If it will reach 10, it will not further count to 11, or if it will reach 0, it will not further drop down to -1 or negative numbers. Okay, so here the input 0.0, it is on the falling edge, so that the car will be allowed to leave first the sensor before it will close the gate. Okay, or it yes, it will close the gate. So same thing with the exit, the countdown, the car will leave first the sensor before it will close the gate. So our input 0.2 is our reset. Okay, and then if B02 here, okay, so B02 and B03, we have it here, B02 and B03. So if B00, okay, and or input 0.1, it will trigger the B02, so that it will move to our analog output, which is output 0.7, okay, to close the gate. Okay, and then this one in turn will open the gate. So we are using move command. So 4095 means it is a 5 volts to open the gate, and here is 0 volt to close. Okay, to close the gate. Okay, and then for our 7 segment drive, okay, I am using a binary coded decimal. So the active or the real-time counting uh, from the counter will be monitored by this function block, and then it will move to our output word. Okay, to our output word here. So and then after the 10th count, in order to prevent the BCD to count or to display A for 10, okay, so when B01 is on, it will move a 0 value, okay, so that will not display the A character, okay, for 10. And then the B0.1 will trigger the output 0.4, okay, output 0.4, so that it will display 1 on the 10's 7 segment. Okay, it will display 1. Okay, so if we will simulate this, okay, so I will reset first, okay, so that the values will be cleared. Okay, values will be cleared. So the counter is also 0. Okay, so if the counter is 0, we can see that if there is no opening and closing of the exit gate, and the counter also will not count down, okay, because the value is 0, and then B00 will be turned on because the value is 0. B00 will be turned on, and then this rung will become false, and it cannot proceed to count down. Okay. However, if we will trigger the input 0.0 for count up, okay, then it will add 1, okay, and then this is my BCD. It will translate it 1 on the 7th segment. As you can see here, the gate, you can see, is open, okay, and then when the car leaves, it will be closed. You can see it here, okay. It will become 5 volts, and then it will become 0, and then it will the 7th segment will count in BCD. And same thing with the exit. If it is if the one car will exit, it will open the gate, this one, input 0.1, and then when the car leaves, okay, then it will close the gate. Okay, so if we will continue to count, okay, and this counter CTUD will count again. Now it's the real value is 5, and then 6, 7, 8, 9, and 10. So there will be no more opening of the entrance gate unless one will leave. It will open again the exit gate, and it will be closed, and then if one car will enter, then the entrance will be open again. You can see here it's 5 volts, and then it will be closed. So still the counter has a value of 10. Okay, so we will try to load this. We will have to create our hex file so that we can test it through Proteus. Okay, so I will stop this, and we will load this program to our Proteus simulation. Okay, so program is loaded, we will see the operation. Okay, so I will play. Okay, and then all the gates now are closed, so we can see here negative 90, so that means it is closed to servo motors, and then the counter here is 0. So if we will count down or try the exit, okay, so it cannot be done because the counter now, so the parking area is empty. Okay, so if one car enters, okay, so the entrance gate will be open, okay, and then if the car leaves the gate, so that there will be no accident will happen. So if the car leaves the gate upon entering, and then it will count 1, okay, and then again opening the gate, and then 2, okay, again opens the gate, and then 3, and then if one leaves, okay, exit gate will be open, and then it will count down to 2, okay, exit gate will open, count down to 1, and then enter again, it will be 2. So we will continue until 10. Let us check until 10. So that is 5, 6, 7, 8, okay, 9, and okay, 10. Okay, so instead of displaying A here for hex value of 10, it will become 0, and it will generate a 1, okay, displayed here on the tens segment. Okay, so it cannot continue further because the maximum value has reached, and then unless otherwise that one car will leave, and then it will again 9, and then another car will enter, it will become 10 again. Okay, so count down again, closing and opening the gate. Okay, so we will go to 0 now, 2, 3, 1, and then 0. Okay, so we cannot continue further. Okay, then the 1 will enter, 1, okay, 0. Okay, thank you. I hope you have learned something today.